Transistors don't light up, and this surely does, and beautifully. I've dreamed of making this energized since I got it about 20 years ago, but then I finally realized that it takes an awful amount of electricity. I was going to use it as a nightlight next to my bed. Vacuum in the tube is good, or the filament would have burnt out. Just about that long is long enough. This tube is a JAN-CAGD-6C21. JAN, I'm pretty sure, stands for Joint Army Navy. CAGD, I haven't a clue. The type number of the tube is 6C21, made by Machlett Machlett Laboratories Incorporated, made in USA. All right, what we propose to do today, I have this auto transformer plugged into a common ordinary 120 volt AC outlet, and it allows me to vary the voltage that comes out of it from 0 up to 120 volts. And that in turn feeds this step-down transformer, which, when it has 120 volts across its primary, then has about 12 volts across its secondary. This tube has a filament which wants just 8.2 volts AC across it, but it wants a lot of current. In fact, when it has 8.2 volts of voltage across its filament is drawing 16.8 amps, and that's why these wires are so thick, because they're going to be handling low voltage but high current. I propose to plug the tube into this socket. I'll put my gloves on first so that I don't get the oil from my hands on the glass of the tube. The only way I know that the tube is getting enough voltage is by putting a voltmeter right across its filament terminals, like so, and then I will observe the voltmeter. In fact, we can do a dry run. I'm going to turn on the auto transformer, and I'm going to vary it from 0 on up to when we get the proper filament voltage across these two terminals. The proper filament voltage is 8.2 volts. Right now we have exactly approximately 0 volts. I'm going to start turning this knob. We now have in the microvolt range, and we now have 1 volt across here, and we're looking for 8.2 volts. So I'm going to crank it up a little more. There's 2 volts, 7 volts, and we're looking for there's 8.2 volts right across these two terminals. And if the tube were plugged in now and everything works according to plan, the filament would be drawing 16.8 amps, and it would be lighted. With all that in mind, I'm going to turn the auto transformer back down to 0. The voltage across the filament terminals drops back down to 0. I'm going to put my gloves on, and I'm going to pick up the tube. It's a bayonet tube, which means there's a little pin sticking out here that drops down into a small slot, and that aligns the tube pins, and we turn it into place, and it's now properly aligned, and we're ready to apply voltage. The only voltage we're going to apply is 8.2 volts to the filament. Normally when this radar tube is working, there are thousands of volts applied also to the plate. That's this metal part you can see through here. and under the plate, between the plate and the filament, is a grid, and the grid potential is applied here. We're not going to do that today. We're just going to see if we can get the filament to light. We're ready. We're going to turn on the auto transformer, and we're going to slowly bring up the voltage and see what, if anything, happens. And we're still in the millivolt range. And we're still in the millivolt range, 2.1 millivolts. I see no light. Just let me think here. I have to think. 2.1 millivolts AC. I'm going to put my UV gloves on. I'm going to remove the tube from the socket. I'm going to turn the auto transformer back up. We have 2.1 millivolts. Oh, it appears that we may have blown a fuse because there is now no voltage coming. We're going to use our meter to test this fuse to see if it has blown. We'll put it on the ohm meter setting. We'll short these together and we should get a 0. There's a 0. A good fuse should give us a 0. This fuse gives us a 0. This fuse is good. So the fuse did not blow. I'm going to put the fuse back in, and I'm going to reconnect the meter to the filament terminals of the socket. I'm going to set the meter to read voltage. I'm going to turn the auto transformer back on. I'm going to adjust it to ask for higher output. Oh, I know what's wrong. Isn't this funny? We're getting no voltage out of this because I unplugged when I turned up the light. Oh, the vicissitudes of research. I will unplug the overhead fluorescent light. The auto transformer is getting power. We're going to start all over. I'm going to start with a test. I'm going to turn the auto transformer on. I'm going to crank it up, and there you see we now have 8.2 volts, which is exactly the number we want. I'm going to turn it back down to 0. I'm going to turn it off. I'm going to put my UV gloves back on, and having now provided the proper voltage to the auto transformer, turn the auto transformer off. I'm going to reconnect the tube, rotate it to its proper position. I'm ready to turn the auto transformer back on. It's set to 0. And now, you see we're still in the millivolt range. We now have 1 volt across the filament. The filament needs 8 to work. Can you see that the filament is lighted? It's gorgeous, a beautiful orange glow. Just at 1 volt, we can take it up further, and you can see what happens. 3 volts, 4 volts. 5 volts. 6 volts, and you know what? That's as bright as a light bulb, and I'm not going to go any further, but I could probably give it 2 more volts. No need to, it is gorgeous already. This was a triode radar modulator, so it had to handle a lot of power. And in fact, in real life, there would have been a wire connected to this cap that would have thousands of volts on it. And there would have been another wire connected to the grid terminal here. And the tube was pulsed, so many times a second it turned off and on. And those pulses were sent out, hit an airplane, reflected back to a receiver, and got everybody in the receiving shack excited. Oh, we have detected an airplane. It's beautiful. It's just beautiful.